after the collision with the ground, the ball leaves the ground with a speed of 11.92 meters per second after the collision with the ground. What do they say? They're saying that obviously the ball traveled down and everything, and then immediately after it hit the ground, it obviously bounced up, right? That speed, that instantaneous speed, the moment it hit the ground and went up, is 11.92 meters per second. 11.92 meters per second. Oh my God. Is it frozen? Okay, it's going to come back now. So that's the speed we're looking at there. Let's just wait for it to come back quickly. Okay, it's back. Okay, now so we all see what's going on, right? It hit the ground at a specific speed, and then here's the ground, hit the ground, and then went up. That speed, that instantaneous speed, it went up with this much. Okay, and then mind you that okay, let's leave that. I'm gonna explain that shortly. Okay, and then they say calculate the amount of kinetic energy lost by the ball during the collision with the ground. Okay, the amount of kinetic energy lost by the ball. So what are they looking for? Okay, the amount of kinetic energy lost by the changing kinetic lost by the ball during the collision with the ground. So this is what they're looking for. I'm sure the ball came from up there and then it hit the ground. It hit the ground. No, just that instant before it hit the ground, it had gained like maximum speed. So maximum speed. So what's gonna happen is that they want to know how much kinetic energy the ball had just before it hit the ground. Ne? They want to know how much kinetic energy before. Okay, let's call it initial, kinetic energy initial. Ne? Kinetic energy, they want to know how much kinetic energy it had just before it hit the ground. And then kinetic energy after it hit the ground and it bounced up. Ne? So what they're looking for, they want to know like the difference between these two. They want to know like how much kinetic energy was lost. Do you all understand the question? Yes. So we're gonna find this kinetic energy, the initial one, and then find the final, and then after that subtract, and then that difference is what we're looking for. That's how much was lost. Okay. So now let us go ahead and do it. So we first of all gonna find the first kinetic energy. The first kinetic energy is as shown. E initial is equal to 1 over mv squared. Ne? Now, what is this velocity? This is the velocity, the velocity this ball was moving just before it hit the ground, and we don't have it. So before we could substitute that, we'd have to calculate it, right? So this is how we're going to calculate it. Look at this. Your velocity here is minus 10. What's 10 what? 7.4, ne? 7.4 meters per second. Remember, we took like downward movement as minus. Okay, so that's the velocity there here. Yeah, as it was traveling down.
Sure.
Again, the initial one up was positive. Yes, Boza?
So let's say 3.2, right? Let's say upwards 3.2, right? You took upwards as positive. So then for 3.2,
No, don't change it. You're
can I
gonna
take
like mess
downwards
things up.
positive? Okay.
Yeah, just keep it that way. Yeah. Yes.
Okay.
But if you
Okay,
do
'cause
that, it's still fine.
yeah.
Yeah, if
'Cause
you
I
understand, if you
forgot
can
when I was
follow it,
doing
it's fine. Eh?
yeah.
But it's I'd say stick with the initial one. If you wanna take downwards as your positive, you can just do that from the word go. Don't like sort of mix it up.
Yeah, because when I was doing my equation, I forgot. Yeah, because when I was doing my equation, I forgot that my 9.8 and my dy was supposed to be negative, so I put them as positive, like in the equation. So then I was wondering, like, if we could switch,
If
like,
if the switch was consistent, if like you switched all the downwards, and then with the upwards, then your answer will still be fine. But if you sort of mix it up, then you won't get the right answer. If you know what I mean. Yeah.
yeah,
Sure. So now let us go ahead and find this
yeah,
this
no,
velocity,
definitely.
the velocity that the ball had just before it hit the ground. So we'll take this one as our initial v. Um, initial v, that velocity was it passed with here, and then this will be our final. Okay, so we have initial V, which is minus 10 meters per second. We have we're looking for a final V. Then we have our displacement delta y. Delta y is going down is minus 15.3 meters because it's going down.
Is it also fine if we used from when the ball
Is it also
At the
fine
very
if
top,
we used
proper stuff.
from
I'll show
when
you.
the ball is
Yes,
at its
yes.
maximum height?
Could have done that as well.
Yeah,
Ne?
and then
Well, I'll do it quickly on the side. Okay, and then what else? Nice one, Poza. What else do we? Yeah, we have that distance. Okay, we also have gravity. Gravity will always be there. Gravity minus 9.8 square meters per second. Okay, now let us substitute. It's still the same formula. This is a very useful formula. I like writing it like this: VU. It's quicker. So this is V final. That's what we're looking for. V initial is minus 10.74 squared. Make sure you square it. If you don't put the square there, my boy, you're out. If you don't put the brackets, you're out. Out. Because there's a difference between minus 10.74 squared and minus 10.74 all squared. This will give you a positive answer. This will give you a negative. So make sure that every time you like deal with substitutions, especially when it comes to squared, you put in brackets. Plus 2 minus 9.8 minus 15.3. Okay, can you just quickly do this thing for me? Tell me what answer is. You can give me the answer there. Quick. What is V squared?
20.38 meters per second.
Okay, that's
V squared.
yeah. What is V squared?
20.38 meters per second.
20 comma?
Oh, V squared. No.
20.38 meters per second. Yeah.
20.38 is V
And then just give me the value here.
meters per second. Yeah.
Are we guys using our calculators or are we just watching? I feel like we're not using our calculator. Let's go with it. Let's use our calculators. So write the direction as well. Write this down, right?
Okay. Yeah.
Yeah. Okay. So this would mean that if you're ever going to need it anyway, you're going to substitute it as negative. All right. So this is how we do this. All of us are happy with that, yeah? Okay. Hot or sharp? Okay. All of us are happy. Fine. Then we could also use, if you wanted to use like this path from the very beginning, from here to there, you could have done this. You could have done that.
Yes, sir.
Your V initial, okay, looking for V final. V initial will be 0 plus 0 squared plus 2. Your gravity is minus 9.8. Then your displacement is this bus. That gives you 21.19. Yeah, minus 21.19. Then you do this, you're gonna get the same speed of 20 meters per second, 20.58 meters per second down. Okay.
38.
Yeah, 38 you say, okay. Sure. Easy, ne?
Yeah.
And then after that, what we do is
38.
we're gonna substitute it to find the initial velocity, the initial kinetic energy. So our mass is how much? 0.5, ne? And then 20.38 squared. What is the answer there? Quick. Speedy, please, guys.
It's 103.84
joules, ne? And then
joules. Sorry.
yes.
It's
And then
100
the kinetic energy final.
Yes, joules. Sorry.
Collision,
Yeah.
35.52 joules.
After
Okay.
the collision,
35.
35,
Okay, you did this now. You
joules.
substituted here. This is the initial. Sorry, this one. You did this one and then put 11.92, right? Squared.
Okay.
You did that, ne? You got how much?
35,52 joules.
5.2 or 3?
52.
5.2. Okay.
Yes.
Joules.
Yes. 35,52 joules.
Okay, fair. So what we do from here is that you're gonna find the difference.
52.
Né? You're gonna go 103.84 minus 35.54 joules. Find the difference. Tell me what the difference is. 32 joules. Yeah. So this is the kinetic energy lost after it hit the ground. Clear, né?